Okay, for this week, we're moving to kinetics of the particles that we will consider forces with and motion together, and we will starting with the rectangular coordinate. Okay, the slide is the same as the slides as I submitted to you before, but I concluded in some part. Okay, yeah, I concluded in some part and I changed the example that's maybe a little bit different from the video. Okay, so for today, we starting with the equation of motion. For the equation of motion in rectangular coordinate system, we will use Newton's second law. Okay, for equation motion that is defined as the force equal to mass times the acceleration. Okay, and for the system of particle, uh we can conclude it in vector and in scalar form like this. It means that the summation of forces, the unbalanced force cause the acceleration, that is the summation of forces equal to mass times the accelerations. Or we can breaking into the vector like this, that is summation of forces in x direction and sum up with the forces in y direction and summation of forces in z direction equal to mass times the acceleration in each direction. Okay, x, y, and z like this. And after that, we can separate each direction to be the scalar form of the equation of motion. Okay, and to mention this, one thing that I would like you to be careful for dynamics is the consistent positive sign convention. Okay, so in dynamics, we have the equation of motion that is summation F equal to ma. So then on both sides, on left hand side, that is the summation of forces. Okay, and on the right hand side, that is the mass times acceleration vector. The sign convention on both sides have to be consistent. Okay, we have to use consistent positive coordinate. Okay, if we use it not consistent, so then the problem we will get the wrong results. Okay, so let's take a look for the example here. Okay, this example is the one of the examples in the slide also, but I will mention to it again. Okay, so we have a block. We have two blocks, block A and block B. Okay, it is released from rest. Okay, so what does it mean? It means that it's starting from the zero velocity for both. Okay, block A has a weight of 9 pounds. Okay, block B has a weight of 15 pounds. Okay, so the floor we have the coefficients of static friction and kinetic friction. Okay, that is static friction is equal to 0.3 and kinetic friction equal to 0.2. Okay, so we would like to determine the velocity of block A when it has moved 1 foot to the right. Okay, 1 foot to the right. For the first condition, there's a problem given us that block A has a weight of 9 pounds and block B has a weight of 15 pounds. For the first condition, it is for problem num problem one. That is weight A equal to 9 pounds and weight B equal to 15 pounds. Okay, and we will see what happened if we change the weight of block B to be heavier, to be 30 pounds, and we will determine the acceleration of block A and block B for that cases. Okay, so let's take a look for the first one. How can we start this problem? Okay, so for this problem, because it is the absolute dependent motion analysis, because it is a Poulet system, so then we will we will starting with the kinematics of the particles first. So according to this, you will see that we have the fixed point. That is the fixed Poulet here. Okay, we have the fixed Poulet here. That is should be defined as the reference point. When we define these points as a reference, so then we can set up the reference axis. Okay, for A, reference axis, it should be the green one. Okay, I may change some color to be different. This is the green one for block A, right? Okay, and you see that from reference point, from reference line. Okay, measure to block A is to the left. It's measured to the left to block A. So then it means that positive sign convention for block A is to the left, is a positive one. Okay, this is important. We cannot uh assume it as like the static without anything, without the reference. Okay, for static, you may assume that to the left or to the right to be the positive. Okay, but for dynamic, it cannot. Okay, you have to set up the reference. If the reference is here, so then to the left is positive. Okay, that is to reduce your confusion. In the same manner for B, okay, for block B, reference line, this is maybe the pink one, okay, should be the reference for block B. And to measure the position of block B from the reference, we have to measure it downward. Okay, so then downward it should be positive for block B. Okay, according to this, we can draw the line SA like this arrow and SB like this. According to this, we can determine the constraint equation that is equal to SA plus 2SB equal to L. According to this, we take the first derivative. We have the relationship of the velocity, and we take the second derivative. We have the acceleration relationship of the acceleration of these two blocks. Okay, and from this, we can conclude that acceleration of block A equal to minus 2AB. Okay, so what does it mean? The negative sign is mean that block A will moving to the right when block B has the positive acceleration. So what does it mean? When B moving down with the positive acceleration. Okay, so block A should have the acceleration in negative sign. That is, should be moving to the right, tend to move to the right, change the speed to the right. Okay, that is make sense for this picture, right? So, and we can conclude for the absolute value. If we conclude in the absolute value, just only absolute value, this means that acceleration of block A should be two times of acceleration of block B. Okay, it is equal to 2 AB. AA is equal to 2AB. Okay, just only the magnitude, but the direction we have to sticking on this. Okay, when we know the kinematics already, we're moving to kinetics, that we have to draw the free body diagram and kinetic diagram. This is very important. Okay, for free body diagram, we separate it into block A and block B. For block A, we cut the free body diagram and draw the free body diagram to the left hand side like this. This is the free body diagram. for block A. We have weight, we have normal force, okay, and we have the tension from the cable, okay, and we have the frictions, okay, and it's equal to the right hand side, that is kinetic diagram. Okay, you see that we have to set up the positive sign convention in the same direction, in consistent direction, So for these cases, when we form the equation of motion, to these cases, we may set up moving to the right as a positive one, But you have to know that if you set up to the right as a positive one, so then acceleration has to be moving to the right as a positive, okay? And the forces to the right as a positive also. So then from this we can form the equation of motion, okay? Starting with summation Fy, that is a summation of force in y direction to determine normal force, okay? And we can use this normal force to determine the maximum static friction. That is, we have the maximum static friction equal to 2.7 pounds and kinetic friction equal to 1.8 pounds. So at first, we don't know is slipping or not, or it is just only at rest. So then for the at rest, it means that the tension is not strong enough to pull the block A to slipping. Okay, so now we can assume that the slipping is occur. Okay, so the block A should be slide to the right. Okay, so according to this, we assume that if it's slide, so then we have to use the kinetic friction. Okay, and we form this equation. And after that, we consider the cases of block B. Okay, for block B, we assume that downward is the positive. Okay, so when we form the equation of motion, we have to set up downward as a positive in consistent of the positive sign convention. So then we have the left hand side, that is downward is a positive. So then WB minus 2T, okay, equal to MBAB. Okay, we have this the second equation. Okay, and we have two equations with we have three unknown, that is tension AA and AB. But we have to not forget that from the previous one that we have AA, the magnitude of AA equal to the magnitude of AB. Okay, so according to this, we can use this relationship, that is the magnitude of acceleration A equal to 2 absolute. This is an absolute value only. Okay, but how about this? We should check the impending motion to ensure that the assumed condition of the problem is correct. Okay, for the assumed condition of the problem is assume that the block A should move to the right. Okay, so we will check that the problem given us that's the correct condition or not by setting up that if block B has no acceleration. So what does it mean? It means that it is in equilibrium for the case of impending motion. Okay, so for the case that if AB is equal to 0, so then on the right hand side it becomes 0 and it is to become in the equilibrium, right? So then it means that the tension in the cable should be 7.5 pounds, that is greater than 2.7 pounds. Tension, because it is the same cable that used to pull block A, so then it should be the same tension. So then the tension is greater than the maximum static friction of block A. So what does it mean? It means that tension of 7.5 pounds can move block A to the right, okay, as we assume. So the condition is correct. It means that we're moving to next. That is, we will solve for the solution. Okay, we solve for the equation 1, 2, and 3. Okay, from equation 2 and 1, okay, we can have the new equation. Okay, and after that, we can solve for acceleration A, B, and AA here. Okay, A, B, and AA. And also we can determine for tension. We can determine for tension. After we have the tension, after we have the tension, we have acceleration of block A. We can substitute into kinematics equation of block A. That is, we can use the equation that we already know for acceleration A. Acceleration is constant. We can use this equation. So then we can determine that velocity of block A is equal to 5.365 foot per second. And it's moved to the right. Okay. For this case, block B is moved down, block A is moved to the right, and T is a tension. Okay. And for the second question, that what's happened if we change block A to be the weight of block A to be heavier, to be 30 pounds. So then the maximum friction, the maximum static friction increased to 9 pounds. So for the impending motion that we checked previously, we found that if we leave block B same weight, that is 15 pounds. So what happened? The tension is just only 7.5 pounds. And then it means that the tension is not higher enough to pull block A because the static friction between block A and the floor is more than the tension. Okay, it is 9 pounds. So then block A has no motion. So then the system has no motion. What does it mean? It means that the accelerations of block A and block B become zeros. Okay. Do you have any question for this problem? Are you okay for that? Okay, no question, right? So then that is complete for this problem.